show that 2 is an eigenvalue of matrix A. So our goal here is that given the eigenvalue lambda equals 2, we want to show that matrix A times vector x equals 2 times vector x has a non-trivial solution. So to get us started, we need to rewrite this matrix equation into something that we can work with. So here we go. We have the matrix A times vector x is equal to 2 times vector x. And subtracting this 2 times vector x from both sides, we have matrix A times vector x minus 2 times vector x is equal to the 0 vector. Now, notice now on the left-hand side that we have this common vector x in both terms. So if we factor that out, we're left with matrix A minus 2 times the identity matrix, and specifically the 2 by 2 identity matrix here, multiplied by vector x is equal to the 0 vector. Now, this is something that we can work with. So what we want to do here, we want to show that this matrix equation has a non-trivial solution. So in other words, if we were to put this in its matrix notation form and row reduce, we should find a free variable. So let's go ahead and do this. Let's convert this matrix equation here to its matrix notation form and row reduce to echelon form. So the first thing that we need to do is take this A minus 2 times this 2 by 2 identity and simplify it to a single matrix. So we know that matrix A is the 2 by 2 matrix 3, 3, 2, 8. And this is going to be now minus 2 multiplied by the 2 by 2 identity matrix. So in other words, we can think about this as the matrix A 3, 3, 2, 8 plus the 2 by 2 matrix negative 2, 0, 0, negative 2. And combining up those like terms, we are left with the single 2 by 2 matrix. We have 3 minus 2 is 1, 2 plus 0 is 2, 3 plus 0 is 3, and 8 minus 2 is 6. Beautiful! Now we are ready to start row reducing. So we have our matrix A minus 2 times the 2 by 2 identity matrix, and we're augmenting this with the 0 vector. So we are taking this 2 by 2 matrix we just found, and starting with our first pivot position, we want to use this pivot to eliminate the entry below it. So if we do minus 3 times the first row plus the second row, this is going to leave us. So our first row remains the same. We have 1, 2. Negative 3 plus 3 is 0. Negative 6 plus 6 is 0. Oops, we did it. Woohoo! We've got echelon form. And we can see here that x sub 2 is a free variable. So a non-trivial solution exists. And we are able to conclude that therefore matrix A times vector x equals 2 times vector x has in fact a non-trivial solution. And we can see that x sub 2 is a free variable. And so we have confirmed that lambda equals 2 is an eigenvalue of A. And so there you have it. This is our beautiful final answer. Now, let's actually go ahead and take this one step further. Let's say that we want to find all the eigenvectors of matrix A that correspond to the eigenvalue lambda equals 2. So how do we do this? Well, we do this by simply taking this matrix in echelon form and finding a general solution for vector x. So here we go. We've got the augmented matrix, matrix A minus 2 times that 2 by 2 identity matrix, and that's augmented with the 0 vector. And again, we've already row reduced this to echelon form, which is in fact actually row reduced to echelon form. So excellent work. We're ready to go. We know that this is equivalent to saying that we have the equation x sub 1 plus plus 2 times x sub 2 is equal to 0, and x sub 2 is free. So let's simplify this linear system a little bit further. So we can say that x sub 1 is equal to minus 2 times x sub 2. And again, we already know that x sub 2 is free. So let's write this solution vector x. So vector x here is defined as this vector in R2, where x sub 1 is equal to negative 2 times x sub 2. X sub 2 is free, so it is just itself. We see we have that common scalar multiple x sub 2 that we can pull out to the front. So that's x sub 2 multiplied by the vector negative 2, 1. And there we have it. What we've found is the set of all possible non-trivial solutions for this given matrix A. So again, we can say that vector x being equal to x sub 2 multiplied by the vector negative 2, 1 is the set of all possible non-trivial solutions to the equation matrix A times vector x is equal to 2 times vector x. So here is our beautiful final answer to this extension to the example. So in other words, what this is telling us is that the eigenvector corresponding to the eigenvalue lambda equals 2 for this given matrix A is going to be any vector of the form x sub 2 times the vector negative 2, 1.